Solving quadratics using factored form. In this video, you'll learn how to rearrange a quadratic equation to be written as an expression in factored form equal to 0 and find the solutions. The zero product property states that if a times b equals 0, then a must be 0 or b must be 0. This property helps us solve equations in factored form if we can set the equation equal to 0. So if we have an example like n squared minus 2n equals 99, then we'll subtract 99 from both sides so we can set this equal to 0. After we subtract 99 from each side, we'll get n squared minus 2n minus 99 equals 0. Now we need to put this in factored form. So we need to find two numbers that multiply to negative 99 but add to negative 2. Those two numbers would be negative 11 and positive 9, so now we have it in factored form. Now we're going to use the zero product property to set each equation equal to 0. So we have n minus 11 equals 0 and n plus 9 equals 0. We'll solve the first equation by adding 11 to both sides, which gives us n is equal to 11. On the next equation, we'll subtract 9 from each side, which gives us an answer n equals negative 9. In this example, we're going to solve each equation by rewriting it in factored form and then using the zero product property. So let's start with x squared plus 8x plus 15 equals 0. We'll start by listing the factors of 15, since we need two numbers that multiply to 15 but add to 8. We can see that the factors of 3 and 5 will add to the 8 that we need. So in factored form, we'll have x plus 3 times x plus 5 equals 0. Now we'll set each equation equal to 0 and solve. So we'll start by subtracting 3 from each side in our first equation, which gives us x is equal to negative 3. On the next equation, we'll subtract 5 from each side, which gives us x is equal to negative 5. Now let's look at our next equation. We'll start by listing the factors of negative 11 and find the pair that adds to the negative 10 that we need. So we'll use the factors of positive 1 and negative 11. And now we'll set each parenthesis equal to 0 and solve for x. We'll start by subtracting 1 from each side, which gives us x is equal to negative 1. Now we'll add 11 on the next equation, which gives us x is 11. So now we have the solutions for both equations. In this example, the graph shows the equation x squared minus 2x plus 1 equals 0. What do the x-intercepts reveal about the function? First, let's review what solutions will look like on a coordinate plane. If it has 0 solutions, then our parabola is never going to touch the x-axis. If it has one solution, it will hit the x-axis exactly one time. And if it has two solutions, then our parabola will hit the x-axis twice. So if we look at our example, it only hits the x-axis once, and that's at the vertex. So this tells us the function only has one solution at the point 1, 0. On our last example, we're going to solve each equation by using the zero product property. Let's start with our first equation. So we need two numbers that multiply to 6 but add to negative 7. Those numbers would be negative 6 and negative 1. Now we can set each parenthesis equal to 0 to solve for our variables. We'll start by adding 6 to both sides, which gives us d is equal to 6. And in the next equation, we'll add 1 to both sides, which gives us d is equal to 1. Now let's look at our next equation. So we need two numbers that multiply to 81 but add to 18. This would be positive 9 and positive 9. So since we have the same parenthesis, we're only going to set 1 equal to 0 since they would both give us the same answer. So we'll solve this by subtracting 9 from each side, which gives us x is equal to negative 9. Now we'll look at our third equation, and we need two numbers that multiply to negative 60 but add to 7. Those numbers would be 12 and negative 5. So we'll set each equation equal to 0 and solve. We'll start by subtracting 12 from each side, which gives us u is equal to negative 12. And then we'll add 5 on both sides on the other equation, giving us u is equal to 5. Now let's look at our last one. So we need two numbers that multiply to 0.01 but add to 0.2. Those numbers would be 0.1 and 0.1. So since the parentheses are identical, we'll just set one of them equal to 0 since they'll have the same solution. We'll solve by subtracting 0.1 from each side, which gives us u is equal to negative 0.1. Now let's summarize what we've learned. Rewriting quadratic equations in factored form and setting it equal to 0 will allow us to use the zero products property to find its solutions. The number of real solutions to a quadratic equation corresponds to the x-intercepts of its graph.